Hello friends. So in the previous couple of videos we have been doing a little bit of understanding on the voltage regulation of the transformer. Okay, so we did the basic definition and we found out the equation for the voltage regulation, and so it's a good time to start with a little bit of numerical understanding so that you get a feel of the numbers which are involved, and in general you get a good idea about the formulas which are involved, right? So let us start today's numerical. There will be around 3 numericals today, and all are not very difficult, but however an understanding is quite great. So you have a 10 kVA 400 bar 200 volt transformer. Okay, so it's a single phase transformer with a percentage resistance of 3%, percentage reactance of 6%, and it delivers 25 amperes to a resistive load. Now this is important that it is a resistive load here. Okay, so what they are asking is that the load side voltage of the transformer is. Now usually whenever they give you the concept of the percentage resistance or percentage reactance and you define the load voltage, rather than doing any long method, it indirectly implies you to use the concept of the regulation. Okay, so let us write down the formula of regulation first, which we have discussed in the previous video. So the regulation, you know, that is defined as V1 dash minus V2 divided by V1 dash. Okay, and this value was equal to RPU, the per unit resistance referred per unit resistance of the transformer, into cos theta 2. Okay, and because it's a resistive load, we'll just keep it as plus XPU into sin theta 2. Okay, anyway plus or minus doesn't matter here, so I'll just put a minus sign also. Okay, it doesn't matter because this anyway the sin theta 2 is going to be 0 here. So let's write down what all are given here. So percentage resistance is given to be 3%, right? So therefore per unit resistance will be 3 by 100, which is equal to 0.03. And the percentage reactance of the transformer is given as 6%. That means the per unit reactance is 0.06. Okay, so this is what is all given here. Other than that, they have given it that it is given 25 amperes is delivered to the load. Of course, this is not going to be important for us. But however, it is given that it is a resistive load. That means this cos theta 2 or this theta 2 is the power factor angle of the load. Okay, so cos theta 2 is given to be equal to 1. That means sin theta 2 will be equal to how much? Cos theta 2 equal to 1, sin theta 2 equal to 0. So what they are asking is that what is the load side voltage of the transformer? Okay, so we can see that the what is V1 dash? Okay, so V1 dash is nothing but the no load secondary voltage. No load secondary voltage, you know that if you draw the equivalent circuit of the transformer referred to the secondary side. Okay, so this is the load. Okay, so this is V1 dash, this is V2. Okay, this is what we see, right? So this is RPU, this is XPU, and this is the current. Okay, so this is value is V1. This V1 dash is nothing but this particular value here, which is 200 volt. Okay, so this will be the no load secondary voltage. Okay, this is E2. This is also equal to V1 dash, and this is also equal to the no load secondary voltage. So V1 dash is given to be equal to 200. Okay, so everything is given here. So we just substitute the values here. So V1 dash is 200. So 200 minus V2 divided by 200 is equal to RPU is 0.03, right? 0.03, and cos theta 2 value is equal to 1. Okay, so plus or minus. Now it's actually a plus value because only for the leading power factor you get a minus value, right? So because it's a UPF load, I can just rub this here. So for the leading load it would have been minus, and for the lagging load it is plus. But anyway, it doesn't matter here because sorry, what I'm doing here, yeah. So the XPU value is given to be 0.06, right? 0.06 multiplied by sin theta 2 is equal to 0 here, right? Sin theta 2 equal to 0. So therefore I will get 200 minus V2 divided by 200 will be equal to 0.03. Okay, so from this we can easily calculate V2 value to be equal to 194 volt. Okay, it will be 194 volt. Therefore the answer for this question is answer A. Okay, it's answer A. So this is the answer. So 194 volt is the answer. So let's move on to the next problem here. Okay, so the next problem is also quite interesting. So you have a 20 kVA bar 200 by 2000 by 200 volt single phase transformer. So again it has a percentage resistance of 2%, percentage reactance of 6%. So what they are asking is that to maintain the load side voltage as 230 volt. So you want to maintain the load side voltage at full load and 0.8 power factor lag. So what is the voltage applied to the primary side? Okay, so again you can see that because you have percentage resistances and voltages involved, naturally the best method to solve this is use the regulation formula. So the regulation formula is equal to V1 dash minus V2 divided by V1 dash is equal to RPU cos theta 2. Okay, now they have given that this is a lagging load, so it will be plus sign. So XPU into sin theta 2. Okay, so this is the basic. So let's see what all they have given here. They have given that the percentage resistance of the transformer is 2%, right? So the per unit resistance value will be 0.02. The percentage reactance of the transformer is given as 6%. Therefore, XPU value will be equal to 0.06. Okay, all these formulas, whenever you are practicing numericals, make sure that you write down these formulas completely. You might have friends who can memorize this directly without writing, but don't be like that. Be in a safe position and make sure that you write down the entire formula at least once or twice, so that these formulas are easily in your fingertips. Okay, these are very important. You don't have to derive it all the time. As an engineer, you are not expected to derive things all the time. You must have general results, thumb rules, etc. in the fingertips, so that you can do the calculations faster. Okay, so that is what engineers in general do. So the cos theta 2 is given to be 0.8 power factor lag. Like the power factor is given to be 0.8. So 0.8 power factor in the lagging condition. That means if cos theta is 0.2, 0.8, and sin theta 2 is 0.6. All these results are very important. If cos theta is 0.8, sin theta is 0.6, all these things you can memorize by practicing questions continuously. Okay, so you don't have to waste time here. Other than that, they have told that to maintain the load side voltage as 230 volts. So you have to maintain the V2 to be equal to 230 volts. So V2 is equal to 230 volts. So that's also given here. So you have to find out what is the voltage applied to the primary. Remember, you have to find out the voltage applied to the primary, not V1 dash. Okay, so you can write down V1 dash minus 230 divided by V1 dash is equal to RPU is 0.02 into 0.8 plus 0.06, XPU is 0.06 multiplied by 0.6. Okay, so if you solve this equation here, I am not going to solve the entire equation. You will get V1 dash to be equal to 210.4 volts. You can use your calculators and make sure that you use your calculators. Whenever I am doing numericals, I am always telling you at least once during the entire session, please make sure you use your calculators and solve the entire problem. Okay. So now you have to find the value of V1, not V1 dash in this numerical. Okay, so you have to find the value of V1. You know that V1 dash and V1 are related by the formula V1 dash is equal to K into V1. Right? This is a basic transformer equation, like E2 is equal to K into V1, or V2 is equal to K into V1. Like that, we have an equation V1 dash, or V1 dash is equal to E2 is equal to K into V1. Okay. So we know the value of V1 dash here. So 210.4 is available. So what is the value of K? So you can find the K from this particular information here. So K is equal to secondary divided by primary, right? So it is 200 divided by 2000. 200 divided by 2000. So you will get here 200 divided by 2000. K is 200 by 2000 into V1. So that means V1 value will be equal to 210.4 divided by 200 divided by 2000. Okay, so V1 value here will be equal to 2104 volts. Okay, so out of these options, you can clearly see that it is answer A. Okay, so the answer is A. So you can clearly see here that in order to maintain 230 volt for this particular transformer with a percentage resistance of 2% and a percentage reactance of 6%, if you need 230 volt at the load side, okay, you have to apply 2104 volts. Okay, so if you apply 2000 volts at the primary side, this voltage if you apply in the primary, you will be getting a value less than 230 volts. So if you apply 2104 volts in the primary V1, V2 you will get it as 230 volts. Okay, so that is the next numerical. So let's move on to the third numerical here. Let's see what is that numerical. Yeah, so we are having the third numerical here. So that what they are telling is that a transformer is connected at 600 volt. Okay, that means it is V1 is given to be 600. It is connected to 600 volt with a terminal voltage on the secondary of 230 volt. Okay, so the terminal voltage secondary is 230 volt at full load condition and 0.8 power factor lag. Okay, so if the percentage resistance is 1% and the percentage reactance is 5%, they are asking you what is the turns ratio, that is A. So what is the turns ratio? So let's write down all the information. So V1 is given to be 600 volt. The percentage resistance of the transformer is given as 1%. That means I can write RPU will be equal to 0.01. Okay, simple. Percentage reactance is given as 5%. So XPU will be equal to 0.05. Okay. So again, the cos theta 2 value is given to be 0.8 in the lagging condition, 0.8 lagging condition. That means sin theta 2 will be equal to 0.6 in the lagging condition. So I don't have to write lag here. Sin theta 2 is 0.6 here. So you have to find what is the turns ratio of the transformer. Okay, so we'll find that also. So let's write down the regulation equation. Again, we'll write down the formula completely. So V1 dash minus V2 divided by V1 dash. Okay, so that is equal to RPU into cos theta 2. Okay, it's a lagging condition, so plus XPU into sin theta 2, right? So this is the formula of the regulation. So we don't know the value of V1 dash, right? We don't know the value of V1 dash, and V2 is given to be, V2 I have not written. V2 they have given to be terminal voltage on the secondary is 230 volt, right? So V2 is given as 230 volt. Okay, so V1 dash minus 230 divided by 230 is equal to 0.01 into 0.8 plus 0.06 into 0.6, right? So this is the value that is given here. So from this you can find the V1 dash value to be equal to, let's see what is the V1 dash value. It is equal to 238.74 volt. Okay, so it is 238.74 volt. Okay, now they have given you the value of V1, okay, and you know the value of V1 dash, and so the relationship between V1 and V1 dash is that V1 dash into K, V1 dash is equal to K into V1. So this is the basic relation of the transformer. So you know that this V1 dash is 238.74, that is equal to K into V1 value is given to be 600 volt, right? So this is 600 volt. So K is equal to 238.74 divided by 600, right? But they have not asked you the value of K. K is the transformation ratio. They have asked the turns ratio of the transformer. So the turns ratio of the transformer A is equal to 1 by K. So it will be equal to 600 divided by 238.74, right? 1 divided by 238.74 divided by 600 is equal to 600 divided by 238.7. Therefore, the turns ratio of the transformer in this case, it will be 2.513. Okay. So if we look at the options here, A is 3.5, B is 5.5, C is 4.5 and the D is 2.5. So this is the closest answer, most accurate answer is 2.5. So the answer is here is D. Okay. So these are three numericals regarding the basics of the voltage regulation. Understanding these numericals are very important because you are using the formulas and you are understanding the usage of these formulas. Okay. So if you like this video, again, please like, share and subscribe the channel. Do please recommend these videos with your friends if they are having any difficulty in understanding these topics of transformers or DC machines, engineering circuit analysis and synchronous machines, etc. Because unless you share these videos, the vision of the channel, okay, which is to provide such videos to a larger audience for free so that everybody can access them, won't be fulfilled. Okay, so I again request you, please share these videos. So till I see you in the next video, it's me Varun signing off and have a great day. Thank you.